Hi guys, today we're going to wrap up chapter 6. We're going to learn the last lesson in section 6.3, and what our lesson is today is actually called the central limit theorem. So before I get into the specifics, I want you to just take a look at this dot plot here. Okay, so if I have this dot plot, and let's say that this was me asking students how many cousins you have. Okay, then that would mean that this dot here would mean one person had 7 cousins. One person had 9 cousins. Another person had 9 cousins. Someone had 11 cousins. This could be someone had 19 cousins. Okay, so if we look, these are the traditional dot plots that we've been working on. All right, now what I want to introduce to you today is a term called a sampling distribution. And a sampling distribution, I-T-I-O-N, there we go, is when you collect a sample and you do the average of that sample. Okay, then you collect another sample and find the average of that sample, and collect another sample and do the average of that sample. So again, back here, this would be one person had 19 cousins, one person had 16 cousins, or whatever it would be. Each dot represents one person. So let's say here that I had n equals 30. All right, well then what it would mean is 30 people, like this dot right here, 30 people would have an average of 10 cousins. This would be 30 people have an average of 7 cousins. 30 people have an average of 21 cousins. So that's a lot of cousins, right? And this is, I just made up this data, but I wanted you to get the idea of what we're working on, right? It could totally be that one person has 19 cousins, right? I have 17, I think. So it's easy to have a high number, for one person to have a high number of cousins. But for 30 people to average up to a high number of cousins is hard. It's a difficult thing to have because there's usually not lots of people with lots of cousins. So to get 30 people to average up to 21 cousins or 20 cousins or something would be a difficult task to have. Whereas, and so it's very unlikely. The probability of this occurring is small. The probability of one person having that happen is high. Okay, it's much higher than the average of 30 people. So what we're going to get into, all right, and I kind of just already talked about this, it's your distribution of sample means, okay? It's using means of all possible random samples of a specific size. So a key item that I didn't talk about back here is that if you have n equals 30, then all of the dots would need to be n equals 30. Okay, and you're saying, well, how does this tie into the normal curve? So what we've been using is we've been using the z-score formula, z equals x minus mu over sigma, right? And that's when we have a sample size of 1. So one person, you know, if you look back at every single word problem we've done up until now, every single one is, what's the probability that one person, or what's the probability that one animal or one student or one test or whatever it would be. Now we're going to get into sample sizes. So if you're working on sample means, then we're going to be using this formula. Okay, z equals x bar is your sample mean, mu is your population mean. Okay, over, this is in the denominator. I actually like to put parentheses around this just because I think it helps organize, like that stays in the denominator when you type it into your calculator. All right, so if we do problem number 1, and we'll go through it and then we can touch base back on the concepts as we talk about it. All right, so it's been reported that children between the ages of 2 and 5 watch an average of 25 hours of TV per week. Assume that the variable is normally distributed and the standard deviation is 3 hours. If 20 children between the ages of 2 and 5 are randomly selected, so n equals 20, find the probability that their average number of hours they watch TV will be greater than 26.3. So we have two averages. We have this average of 25, and then we have the kids' average of 26.3. So you need to decide which is which. X bar is your sample average. Mu is your population average. So for the entire population, that was this 25 we had at the beginning. That's your mu. And then our 20 kids have an average of greater than 26.3. So I'm actually going to change this to a greater than 26.3. That's our sample average, because a sample of 20 kids would have an average that high. So when we draw our picture, the population average goes here. So whatever notes you want to write to yourself, mu still goes here like it did on all our other examples. This X bar, our sample average of 26.3, is going here. And we are going to shade to the right. Okay, because we went greater than that. It's going to seem like the same process, but what we need to make sure we pay attention to is when we do our z-score formula, we're going to have X bar minus mu over our sigma is 3 and our square root of n is root 20. Now, when you type this in your calculator, and I apologize, I don't have my calculator near me, but you're going to hit Control Divide to get your fraction bar, type in the top, then click your cursor in the bottom and hit Control Divide again, and it's going to give you a new fraction, okay, just in the denominator. And when you have that, and really guys, make sure you test this out, because I can't tell you how many students write it down perfectly and they get a different answer, and then it changes everything else. Make sure that when you type this in, you come up with 1.94 as your answer. All right, if you don't, I need you to let me know, and I can help you, problem solve on the Google Meet or in class, whatever we've got going on when we work on that. So first we drew the picture, second we did the z-score. So now third we need to find the area. Okay, so for the shaded area, we need to now look up our 1.94. We're still using our green chart, right? Our z-score chart. If you've got z equals 1.94, that's going to be here now. Remember, z-score will have a mean of 0 if we want to think about like getting rid of those. All right. So when we look up 1.94, we're going to get 0.9738. That goes here. We need our shaded. So our shaded area is 1 minus 0.9738, which will leave us with 0.0262. That's our answer. There is a 2.62% chance that 20 kids will have an average greater than 26.3. All right, that's what this problem is representing, an average of hours of TV that they watch. That's the context of the problem. So let's do another. All right. So if we talk about the average age of a vehicle registered in the United States is 96 months. We want to assume that the standard deviation is 16 months and the variable is approximately normally distributed. Oops, so this is sigma. Our mean for the whole United States was 96, so that's our mu. If a random sample of 36 vehicles is selected, we want to find the probability that the mean of those 36 vehicles, the mean of their age, is between 90 and 100 months. So when you draw your curve, if our mean is 96, our population mean, we want to find the probability that these 36 cars have an average between 90 and 100. So what does it mean when we have two numbers over here? Okay, that means that we need to do the z-score formula twice. We need to do the z-score formula here, and we're going to need to do the z-score formula here for the 100. So again, it's z equals x bar minus mu over sigma over root n. It's not a bad idea to write it down each time, okay? We're going to have 90 minus 96 over 16 over root 36. Again, please practice typing this in your calculator. Okay, Control Divide to get the fraction. Type in the top, click in the bottom, hit Control Divide. You'll get a new fraction and you can fill it all in. You should be getting negative 2.25. All right, for the second z-score, we're going to have 100 minus 96 over 16 over root 36, which would give us our second z-score of 1.50. So now, remember, when you have your z-scores, we know that the z-scores pair with these numbers, but we don't subtract the z-scores. We have to look up both of those areas and then subtract the areas. That's what we wind up subtracting. So if we take a look, when you look up negative 2.25 for a z-score, that gives you this area, and that's 0.0122. And then when you look up 1.50, that's this guy, and it should give you 0.9332. So then last, our shaded area to find our answer is 0.9332 minus 0.0122. We get 0.9210, or a 92.1% chance that 36 vehicles will have an average age between 90 and 100. All right, so next problem. Example 3. The average number of pounds of sugar that a person living in Sugarland consumes each year is 218.4 pounds. That's a ridiculous amount of sugar, totally fictitious. All right, so our average is 218.4. Assume that the standard deviation is 25 pounds of sugar. Oh my gosh. Just for visual, the bags of sugar you buy like at ShopRite to bake are 4 pounds of sugar. That's a lot of sugar. That's an exaggerated problem. All right, so, part A. Find the probability that a person selected at random consumes less than 224 pounds per year. So, you might be saying, well, what do I have, right? What's the N? If we have a person, this is the old lesson. Right, this is what we've been doing in section 6.1 and 6.2. N is just 1. When you select a person, that's when we're going to use z equals x minus mu over sigma. Right, because now we need to be able to read these problems and identify this. If we're selecting just one person, then that's what we're going to have. So you draw your picture the same way we've been doing. Mean 218.4. One person, 224, we went less than that. All right, so when we plug in our numbers, 224 minus 218.4 over 25, we get 0.22. Be careful, that's not our area, that's not our answer, that's not probability, that's the z-score. So you need to look up your z-score of 0.22, and when you do that, you get a shaded area equal to 0.5871. So this area here is 0.5871. Okay, or a 58.71% chance that a person consumes less than 224 pounds of sugar per year. Okay, now Part B changes. Part B is saying if a sample of 40 individuals is selected, find the probability that the mean of the sample will be less than 224. Now we have n equals 40. So we have the same picture, right? Because it's still less than 224. So we have 218.4, and we have 224 here, and we want less than that. Okay, but when you have a sample size, you have to notice that we need to switch to the sample size formula. All right, so you should have x bar, the average is 224 minus 218.4 over 25 over root 40. And when you plug this in your calculator, our z-score is 1.42. Z-scores represent how many standard deviations above or below the mean the data point is. This one is barely above the mean, right? It's barely one, it's not even close to one standard deviation. If a standard deviation is 25, it's only a little less than 5 away. Whereas this, our standard deviation changed because we did 25 divided by root 40. So when you talk about an average, now we are almost 1.5 standard deviations above the mean. When you look up the z-score of 1.42, you wind up with this area being 0.9222, and that's our answer. Okay, 0.9222, which means that there is a 92.22% chance that the average for 40 people will be less than 224 pounds of sugar per year, right? It's going to be, if you have 40 people averaging, it's going to be much less likely for it to be above, right? Which means it's almost guaranteed that it's going to be lower. Okay, one person, 59% chance. 40 people and their average, it's a 92% chance. All right, so what I would like you guys to do is I would like you to do number 4 on your own. Okay, don't do number 5. We'll talk about this later because this one's different. It's asking you a different concept. And I'm just going to tell you that your answer, this answer should come up as 0.5359. All right, and this answer should come up as 0.7088. All right, so number 4A should be 0.5359. 4B should be 0.7088. If you don't get these, let me know. All right. We'll go over them in class, certainly, if you want to. If you get them, great. You know, draw your curve. Really pay attention to your sample size, right? Is there a sample size or is it just a sample of one? Good job today.